Hello Internet, my name is Quentin and this is Blondihacks. I'm working on my locomotive this week and I'm going to finish the front and rear box lamps, including all of the internals that are going to light the right of way for our humble little locomotive. So let's go. When last we left our box lights, we had the case done. Now it's time for the internals. This is where I'm going to go off script. The drawings that Kozo did call for an incandescent bulb that threads into an aluminum reflector, and then this is powered by a AA battery that's hidden remotely inside the air compressor tank underneath the cab. And this was a very clever design for the technology that was available when this book was written. However, nowadays we have much better things that we can try. What I wanted to do was an idea given to me by a viewer who has built this locomotive. He said that there's actually room in here to fit a high-powered modern LED and a lithium coin cell all right inside the lamp, thus not requiring any external power source and not running wires down the side of the boiler and so on, which sounds like a terrific plan to me. So I ordered a bunch of stuff to hopefully make this work. I got the brightest 5mm LED that I could, and I also picked up some of these little holders that you can get for 5mm LEDs. They have a little threaded clamp on them, just like a switch, like a panel switch. So this should go nicely where the little incandescent bulb would go, and it should be a lot brighter. And then for a power source, I found these nifty little coin cell holders at my local electronics shop. They hold a 2032 cell, and they have an on-off switch built right into them. So I'm thinking I should be able to incorporate this right in, save me a lot of hassle, right? Well, maybe. Now, fun fact about coin cells, if you're not aware, they have a very high internal resistance on them, which means you can short directly across them with an LED like this. You don't need an inline resistor. This is very different than other lithium batteries, such as would be in your phone or in an EV, where the internal resistance is very low, specifically because they need the ability to dump a lot of current very, very quickly and be able to be charged very quickly. Thus, the coin cell will save me a lot of fooling around. I don't need an extra resistor in there and so on. Just to put a fine point on that, I'll put this in series with my ammeter, and you can see that it's drawing negligible current even when dead shorted across that battery. Now to figure out how to get my electrical in here, I thought I could use this coin holder maybe just as is somehow, if I could work it into the case, but honestly this thing is a lot bigger than I was hoping it was going to be, and I didn't like how this was going. Plus, by the time I get the LED in the center there isn't going to be a lot of room in the back. I started taking things apart to see what are the minimal elements I can take out of this to maybe make it all fit. Because the overall volume is fine, it's just really the form factor that's the problem. And I decided, well, maybe I can use some pieces out of this and 3D print my own solution instead. And in fact, I went over to CAD and I sat down and started taking measurements to model something that would do the job, when I realized actually all the elements I need are already here in this factory plastic. I just have to cut away the stuff that is in the way. So let's do that. What I really want out of this is the contacts that hold the coin cell in place and make contact, and the switch itself. Most of the plastic around it I don't actually need. So this looks a little ugly, but that's the bare minimum out of that thing that is going to do the job that I want. So let's see if we can make this fit instead. I'd like to mount everything to the back plate of the lamp so that it's easy to pull it apart and change the battery, of course. That's going to need to be done. So I'll make the back plates over on the shaper, because shaper. I'm really making this up as I go along, as I'm sure is painfully obvious, but I'm just figuring out how I'm going to mount this in here and how much space everything needs, kind of all at once. I decided I could make some sort of a strap that would wrap around the battery case and hold that tight against the back panel. So I'm going to want to bend that, and I decided to anneal this, and I'm going to bend it with a hammer form rather than just, using your vice jaws or some pliers or something, even though it's a simple strap. Because when you want really sharp corners on a bent piece, like as close to 0 corner radius in there as you can get, you can't beat hammer forming. No amount of pliers or hammering over the edge of your bench or anything is ever gonna make a corner that's very tight. You're always gonna have a corner radius. And when space is this tight, like every fraction of a millimeter counts in this thing, I want those corners to be tight, tight, tight. I scribed a center line on the hammer form and one on the strap, and I clamped that in place, and then I tap the end of it all the way around, which is very easy, of course, because it's annealed, so it's nice and soft. I did the same thing on the other side, and you can do a little bit of work on the anvil as well if things need straightening out or depoofing a little bit here and there. But there you can see what a nice job that does. You can get effectively 0 corner radius bends on sheet metal with a hammer form, which I don't think you can really do any other way. I made them overly long to make sure that the bends ended up in the right place, and I cut and filed those down to final length so that they're a nice snug fit over the battery holder. I want the battery to stay in there by friction. And now I'm going to solder this onto the back plate. I'm going for plumbing solder here, not silver solder. Soft solder is a whole lot easier, and well, this headlamp is sitting on top of the smoke box, so it's probably going to get warm, but if it gets too warm for soft solder, then the plastic battery holder and battery and LED are toast anyway, so this is going to have to be okay. Quick sidebar on that subject. My viewers are amazing. They really are. A lot of you have built this locomotive, and one of you has not only built this locomotive, but put a thermal camera on it so we can see how hot different sections of it get. This is fantastic. Thanks Mike and Norm for letting me use these photos. You can see that quite counterintuitively, the smoke box actually gets hotter than the boiler. And that boiler does not have lagging on it. So that is the natural temperature of those two things. And this really surprised me. I have been assuming all along, as I've said in these videos, that surely the smoke box doesn't get as hot as the boiler does. But it actually gets hotter. I guess all of the exhaust gases coming out those smoke tubes and the exhaust jet inside there just really heat everything up. However, the good news is you can see the headlamp is quite a bit cooler. It looks like it should be okay for the wiring and everything. And I am cautiously optimistic that the number badge looks okay. It's still below the temperature of plumbing solder, which is what I used to attach the number on that plate. As you may recall, I was a little worried that it might get too hot and the number would fall off, but I think this is going to be okay. The locomotive shown in this image is sitting on a rolling road and it's being fired with coal. So this is all like the same temperatures that mine will be in principle. So cool. Well, I guess hot, actually. Anyway, here's the final strap cleaned up after soldering, and let's do a little test fit with my battery holder. You can see I've got the switch kind of facing backwards because the idea is going to be that the switch will poke through the back plate. So this whole assembly will be flipped over on final assembly, but I'm just test fitting it with the switch facing the other way here so I can see if that's going to work. And it's certainly sturdy in there, so far so good. I'm confident enough in this to put the mounting holes in the back plate now. I should have paid a little more attention and realized that these need to be countersunk from the other side, but no biggie. Used an end stop to flip that over and get the countersinking tool out. Could have saved myself a setup there, but you know, it's fine. Don't worry about it. Shut up. I always find countersinking immensely satisfying. When I have a bunch of them to do like this, I do the first one a little bit at a time until it's correct, and then I set the quill DRO to 0 on that, and then do all the rest of them to the same depth, and that's always worked for me. This countersinking tool is one that I made on my D-bit grinder, and I'm quite proud of it. It works very well. All right, so we can bolt that back on there now, and now I can start kind of laying things out on the inside and see how it's all going to fit. So the strap fits inside there. That's a good sign. I'm going to make the rest of the components now, and I'm going to stick to the drawings for this first part, which is a brass ring. This is both decorative and holds the glass on the front of the lamp. There's no reason to deviate from the drawings on this because this is all going to fit no matter what. I cut myself a chunk long enough to get 2 of them out of in one setup because, of course, we do have 2 of these lamps, so I'm not showing you all of that, but everything you see me doing, I am, of course, doing twice. This is nice, thick material, so I don't have to worry about stick out. I didn't have to get out the steady rest that way because the bar stock here is too big to go through the spindle bore on my lathe, so it does mean a little bit of waste. It's always nice if you can avoid cutting the original bar stock and feed it through the headstock, thus saving you offcuts. But here we are. So now I'm going to turn the OD of this down, and then before I do anything else on the OD, I'm going to punch the great big hole through the middle of it because we're going to lose some strength in the outer shell of this part when we're done. It's going to be pretty thin, and these big drills that I'm about to use are going to put a lot of torque on everything, so the brass could distort under the force of drilling if I don't do it now while everything is still thick and strong. That is an issue I have run into before. For example, when making pens on the lathe, I've made a couple of brass pens, and I've learned to drill the hole first before turning the OD because the final part ends up very thin, and the cutting forces from turning the OD are very small compared to the cutting forces of the big drills. Then I bring this to final dimension with the boring bar. So there's one large bore that goes all the way through the part. Once that's at dimension, then I come in and I do one more cut to create a very thin shoulder at the front edge of this part. And that little shoulder is what's going to hold the piece of glass on the front of the lamp. Because of that shoulder feature, I had to turn the part in this orientation on the lathe, which means the next feature, which is to reduce the diameter of the far side, is going to be a little bit trickier because I couldn't flip the part around and make this a normal turning to a shoulder operation. I did this with a grooving tool using a series of plunge cuts close to final depth, and then I go right to final depth and sweep across to make a nice even diameter. You could also do that with left-hand turning if you wanted, but it's kind of 6 of one, half a dozen of the other for a feature this size. Then using a small grooving tool, there's a little decorative groove at the end, which will become kind of a deco detail line on the outermost part of the lens, as you'll see. That gets yahtzeed off, and that is it. That is the brass ring that holds the lens. It's a pretty straightforward part. Some important dimensions in there to make sure it all lines up right, but not too bad. Let's slide it into the body and make sure everything's going to fit. You'll see how this sticks through the body and creates the decorative look of the lamp out on the front. It's quite a nice looking detail, actually. It's a pretty elegant design of Kozo's to get all of this detail through a series of interlocking parts. Now inside that goes an aluminum cylinder with another series of steps on it, and I'm going to use something new for me. This is 2011 aluminum. One of my least favorite things in the shop is turning aluminum, 6061 in particular, because it does not break chips, and I just hate it. It makes a mess. It's really difficult to manage. So I looked up this stuff, and this stuff is a free machining aluminum designed specifically for this. I bought it in the hopes that it would free me from the purgatory of turning 6061 on the lathe. Now the facing is about the same so far, nothing too dramatic there, but the proof will be in the turning. And oh my goodness, look at that. My jaw hit the floor, metaphorically. I'm being safe. Don't let your jaw hit the lathe. But this just blew me away. Look at that break chips. Not even actually using the correct tool geometry for aluminum. The top break should be a little higher than it is on that tool. But wow, that is throwing chips like 4140. Just turning incredibly well. Well, I am converted. 2011 aluminum all the way. I am never turning 6061 again if I can help it. The only downside I could find is that in addition to making chips, it throws this weird kind of aluminum dust everywhere. It literally covers everything in a 5-foot radius in this white aluminum powder. I don't know what that stuff is, something to do with the alloy, but I don't mind it. It's easy to clean up. You know who's unhappy about it though is Swarfy, because this means he's not going to get his bird's nests. So I might have to go back to 6061 because I don't think I'm going to like Swarfy when he's angry. I turned him to face the wall so he can't see the rest of this turning because I am in love with 2011. Look at that. Oh, such a joy to turn. No long strings, no bird's nests, no razor blades of death. Now's where I start deviating from the drawing a little bit. This is where I would put the threaded hole for the incandescent bulb, but instead I'm going to drill a clearance hole for the LED holder that I showed you earlier. I considered using those threads and just threading this thing in, but there's no wrench flats or anything on it, so if it ever got stuck in there, I think I would regret doing that. So I'm going to go with a clearance hole and put the nut on the back of it. Next, I need a counter bore for the bezel on that LED holder. I did that with an end mill because I am lazy. That counter bore establishes the bottom of what's going to be the reflector, and this is where things get interesting. This is the trickiest feature on this whole internal assembly. I'm going to start by using my boring bar to establish the top edge of the reflector, and as you can see by the drawing in the corner, this needs to be some sort of a bowl shape, if you will. Now, there's a lot of ways you could do this. Of course, the ideal shape, as you probably know, would be a parabola with the light source at the focus of the parabola. That guarantees catching all of the light and sending it forward out the front of the headlamp, which is what you want. And you could do some step turning calculations here. You could make a paper template and turn to that. A lot of complicated, fancy ways you could do this to try and get a perfect parabola. What I did is eyeball it, because the fact of the matter is this just doesn't matter very much. It doesn't need to actually function as a perfect parabolic projector. It just needs to kind of look like a headlamp. After eyeball step turning the overall shape with a boring bar, I had to figure out how to refine that shape now. I tried a bunch of stuff. I tried a round file, but that just really didn't work very well. Sandpaper worked a little better, but it was really, really slow. And you know what actually ended up working great was a carbide burr on the rotary tool. This is not something I've done on the lathe before, but holy cow, this worked great. It gave me really good control. The material rate was just right. It was fast enough that you could see something happening, but slow enough that you had good control. So I could get rid of all the step turning marks and refine the shape and get a really nice parabolic-ish bowl in there. Now it does chatter a lot, so it left a rough surface, but that's okay. That was easy to then remove with some 80 grit sandpaper wrapped around a file to give it a good backing. And then I went up to 120 grit, and then from there I went up to 320 grit and just refined the surface, finally going to 1000 wet and 2000 wet. The wet in this case is WD-40. It's what I use for wet sanding. And the goal, of course, is to remove the file or sandpaper marks from the previous grit with each stage. For the final step, I have these little buffing wheels for the rotary tools. I put some jeweler's rouge on that and gave it a polish. And holy cow, did that ever work well. Look at the shine just appear on that. Metal polishing is really addictive once you sort of get the hang of it. I'm not great at metal finishing, but I'm practicing and slowly getting the hang of it a little bit at a time. So I'll pop the LED holder in there and you can kind of see the overall effect. Woof, that thing is really shiny. Look at that. That is awesome. I can't do any more from this setup, so I will Yahtzee it off and make a second one, of course. Funny thing about doing stuff like this is you always get a little better at it each time. So the second one actually came out much better. I got a little bit better bowl shape on it, and I didn't have the rogue tool mark that the first one had that I couldn't quite get rid of. I went a little too deep on one of my step turns, but yeah, the second one came out a better shape, and I got a better polish on it. I turned the overall length to be flush with the back of the case because from here on out, I'm completely on my own. We're going to deviate entirely from the drawings. I know I'm going to need to carve out something for all the electrical in there, and I just wanted to give myself the maximum material to work with. You can see there's a little gap here between the aluminum and brass rings, and that's where the glass is going to sit, so that all looks correct. Now to figure out how I'm going to stuff the electrical in here. I did a lot of measuring and fiddling and staring and measuring and fiddling and staring, trying to figure out how I was going to do this. I didn't have a very good plan. I probably should have modeled this in CAD, but I ended up winging it instead, which took a lot longer, but you know, I got there in the end. No matter what, I know I'm going to need a space for the battery to sit, so I set this thing up in the mill, centered it up, and then milled away the minimum pocket on the back that would fit the battery. The goal is to have all of these components touching inside the lamp so that everything is held in place by being captive. There's not going to be any fasteners or glue or solder or anything inside this assembly, so it will all come apart in the end. So that little pocket there is going to hold the battery, but I didn't know what to do with the switch yet. So as I say, I'm just doing one step at a time and figuring it out as I go. So the back plate will go on there with the battery inside that strap, of course. The switch is going to be a little trickier, but I did figure I could mill a tiny little pocket in the remaining material to hold the switch. And this is a little bit shallower, and it's, again, just big enough to hold the switch with no movement whatsoever, but also no fastening required. That seems to have gone well. The switch is a really perfect fit in there. That's going to be held in by the outer brass, of course, as well. So again, no fasteners required. It's going to sit flush like that and stick through the back plate. So far, so good. Once I knew where that was going to end up, I could drill and file out a hole for that in the back plate so I can get the back plate installed and figure out the rest of the details. I'm going cautiously here, one step at a time, trying not to paint myself into a corner, but it does mean I had to do a lot of extra setups on the mill because I had to give up my setup between all of these operations, but I didn't want to try to do too much at once. Now comes the electrical, and I should have probably planned better here. This is where a CAD model would have really helped because figuring out a good routing for the wiring was difficult, and the wiring took up a lot more space than I expected that it would. Which is always the case with wiring, isn't it? It always takes up way more space than you think it will. I did have to go back and make a couple of small changes to the aluminum block here and there to make clearance for things, but I ended up with this, where the LED is sticking forward, and the switch is wired in like so, and then it all sits flush against the battery strap, and there's Captain tape on the battery strap to insulate it from the back of the LED, and that's all working okay. However, this is not very elegant. It's very clunky and messy. And I'll save you a whole bunch of extra fooling around that I did to try and make all this work. And in the end, I decided all of my problems were really being caused by trying to use that factory plastic battery holder. I wanted to use it because of the copper contacts on it, which have to be very specific shapes to hold a coin cell. And there was a little bit of probably psychological sunk cost involved here because I had bought those things and I was determined to use them. But in the end, I realized they were really causing me more trouble than they were saving me. I was also going to a lot of trouble to isolate all the electrical from the chassis, and I eventually realized I really didn't need to do that either. So I could simplify everything by 3D printing my own battery holder and using the chassis as ground. So this has a hole in it because otherwise there's no way to get the battery out. So you can push it out from behind, and it holds the battery upside down and a little bit proud of the surface so that the negative side of that battery is pushed tight against the back of the brass strap. So now we have our chassis ground. And then the positive lead is just a bare wire trapped underneath the battery, which again works just fine, nice and simple, don't need the fancy copper contacts. And this halved the wiring because one side of the back of the switch is also grounded to the case, so all I had to do was run wires to the LED, which is easy to do, and that made a much nicer package, much more compact, much simpler, much easier to install and access everything for maintenance and so on. I did have to do a little bit of chasing of shorts because there are some bare connections in the back of the switch and such, and of course everything is metal, so I had to do a lot of careful insulating of various things using a combination of Kapton tape and little drops of high viscosity gel super glue. This is a trick I've figured out from my HO model railroad. Gel super glue makes a nice insulator for really small electrical connections. With that all sorted, I could go on to the lenses, which I'm going to make from acrylic. This is actually the same acrylic I used for the oil tank, as you may recall. The book suggests going to an optometrist and having them grind you a glass disc for this purpose, which is a very fancy way to do this. That's not something I have the ability to do here locally, so instead I went with the acrylic, which I've learned previously is quite easy to work with. It cuts really easily on the bandsaw with a fine-toothed blade running very, very slowly. And then I did a little bit of sanding as well to refine the shape of it. It doesn't need to be perfectly round as long as the edges are fully concealed by that lip that is retaining it. In theory now, this should all go together if I've done everything the way I think that it's all going to work. This all slides together like so, and then once the brass plate makes contact with the aluminum inside, then all the circuitry is complete, and the switch works. Look at that. It's a light that I can turn on and off with a tiny switch on the back. That makes me very, very happy. Then off camera, I made these base plates. Kozo has you make these as a separate piece. It's an extra detail liner on the bottom just because it's easier to make it as a separate piece. And that all bolts together on the top of the locomotive, front and rear. And there it is installed on the top. Look at that. That is awesome. Let's give it a little test drive. Ah, look at that. Now, interestingly, it's not very bright from this angle because, look at that, it's actually projecting the light forward really, really well. I'm really surprised how well the eyeballed fake parabolas that I put on the aluminum work. They really do project all the light forward. It's easier to see on the back here. I can get more of a straight-on view for you. Turn that on, and you can see how much brighter it is when you're close to straight on with the light. Here's that same light from the side, and you can see how much dimmer in appearance it is from the side, which means the reflector is doing a good job of capturing all the light and sending it forward. Not that it needs to, it just needs to look like a lamp, and I think it does. I'm really, really pleased with these. These were an incredible amount of work, honestly. Multiple weeks in these things, and I'm not going to lie, I spent the better part of a week just figuring out the stupid electrical inside. That was a lot harder than I thought it was going to be, and I made it hard on myself in a number of ways, but I got to a solution I'm really happy with in the end. That's how it goes. That's model engineering. Well, thank you so much for watching. I hope you enjoyed this. Thanks to my patrons for making all this happen, and I will see you next time.